Now, in order to be able to figure out how to find an angle, we have to first know a couple of sides. We have to know what we're looking at and which angle you're trying to find. For example, if I take a basically, if I need to find that angle, what we need to be able to do is figure out, first of all, which of the trig functions we have to do. So we start by listing everything out just like we would normally.
You do the cosine.
That's the angle, yeah. So what I would do is maybe instead of using the question mark, remember how I've been using that symbol theta for the angle? Theta. Why don't we go ahead and just use theta for the missing angle? Okay. So when we're at theta, remember theta always looks at an opposite, which makes 14 the. I don't know. This is that we're not going by any numbers in the book whatsoever. It's just more trig. 14 becomes a what?
7.7.
Is that what it is?
Yeah.
All right, and then 23 obviously is the hypotenuse. Okay. So we have our diagram listed, or labeled, excuse me. Do you need paper? We have plenty of paper. Get paper out. It's February. I shouldn't have to remind you. Shh, guys. What trig function do we use?
Cosine.
Cosine. So we write it out. The cosine of some angle is 14 over 23. Okay? Now we have to sit there and think about how do you undo things. Now, when you think about algebra and you think about multiplying, dividing, adding, subtracting, we always talk about what we're called, well, what's the opposite of multiplying?
Dividing.
What's the opposite of subtraction?
Adding.
What's the opposite of square rooting? Squaring. Now, each one of those are called inverse operations. Inverse operations undo one another. What they do is they create factors of 1. Okay? An inverse, it makes something have it basically turns something into a 1. For example, what is the inverse of 2?
-2.
What would I multiply 2 by to turn it into 1? In other words, instead of divided by 2, I'd say multiply by 1/2. So 2 times 1/2 is 1. Now, in your calculator, there's a button that looks like that, a -1. Everybody see that? If you put 2 to the -1, what do you get? You get half. That -1 symbol stands for inverse. When you get to algebra 2, and you're going to want to find what's called an inverse. They put this tick mark there. There's inverse relations. Okay, it's what makes that. Excuse me. I know. I got it.
Oh, can we get a new teacher up there? Because I don't want to be sick.
I'm not gonna get you sick, Whiskey.
Oh, yeah.
So what we're doing here is we're looking for an inverse relationship that can undo this. Well, just like you would before, if you had to undo multiply, you'd divide both sides. If you had to undo add, you'd subtract both sides. If you had to undo squaring, you'd square root both sides. Well, what we do here is we take what's called the inverse of both sides. We take the inverse of both sides. This inverse of cosine to the -1, times a cosine, undoes one another. It undoes it. It leaves you just theta. It's how you multiply these two together to make cosine go away. Well, how do you undo cosine? You inverse cosine. How do you undo sine? You inverse sine. How do you undo tangent? You inverse tangent. So in the calculator, there are buttons that do this. You see how you have sine to the -1, cosine to the -1, tangent to the -1 on your calculators? Those are the those are the buttons that you're going to press only when you have to find angles. Oh, there it goes. These buttons here these values here, this sine inverse, cosine inverse, and tangent inverse, those are only for when you have to find an angle value. You never use them otherwise, okay? So if I'm finding, and I still set up the same way, I'm going to use the cosine inverse if I have an adjacent and a hypotenuse. I'll use the sine inverse if I have opposite and hypotenuse. Same rules apply, it's just a different button structure that you press, okay? So if I go back to what we had here a second ago, we have that theta is going to equal the inverse cosine of 14 divided by 23. Well, here's all you have to do in the calculator. In your calculator, you press second cosine. Notice how it makes a parenthesis? And just type in 14 over 23 and hit enter. And there's my angle. It's only one extra button that you have to press. The second button. That's it. I have increased your workload by, bless you, by one button. I'm sorry. We could also give you guys trig tables and have you look for it backwards.
Yeah, yes.
No,
Yeah, I'm joking. Boy, I'm smarter than you will ever be in a million years. I'm smarter than you will ever be in a million years.
Yeah.
You say something, you just say that again, nigga?
Yeah.
Huh?
Guys.
Like a dumbass.
So again, whenever you try to find any trig inverse will equal your angle of some side over side. Only use, oops, I know how to spell the word use. Only use trig inverse to find theta. That is the only time you use it. Otherwise, if you start using it to find side lengths, more often than not, you're going to get errors or just completely incorrect value. Okay? Yeah. Okay. What you're doing here is that an inverse value is 1 divided by cosine. So when you have 1 divided by cosine times cosine, you get cosine over cosine. What's anything divided by itself? 1. It's 1. Because what this does, if I take some trig value times the trig inverse, this is the same as trig, which gives you and anything divided by itself is always 1. That's how it undoes itself. That's why when you have these things put together, times that theta, think of that theta as that variable, as the x, as it's going on down the line. So if it's sine times inverse sine, it's 1. Tangent times inverse tangent, it's 1. It's undoing it. But since there's this equal sign, you have to do it to both sides of the equals to keep it balanced. That's why this works. Because this inverse function does that. Did you find them on your calculator? Just I forgot you had that one. I think you have to hit angle on yours. Oh, that's right. There's a button that says trig, and then it's in there, right? Does your calculator default to degree mode? Do not check that. If you hit the, I think there's a button that says mode, I believe. Just make sure it defaults to degree. I think it should. And the one below, does it say degree, DEG or anything? Okay, then you're fine. It doesn't say, yeah, because that one will just default back and forth from time to time. If you ever drop that one, Justin, the batteries fall out or anything like that, always go back to your mode to make sure, because sometimes it defaults itself to radian. And then if you do that, then it just, yeah, it's all things bad things, okay? That's what this stuff does, guys. That's all this does. This is the next natural progression within this stuff, finding angles. Let's try another one. Remember, use theta for your question mark. Use theta for your question mark. Use theta for your question mark. It's TH. Always circle the angle that you're starting with. You're looking at the side. 4 is it's an opposite. 5 is an adjacent. What trig function am I going to use? Very good. So I always start by writing it out. The tangent of theta is 4/5. Which means to undo tangent, you use what? Tangent inverse. So if we inverse both sides, we get theta will equal the inverse tangent of 4/5. Sure. What was it? Well, there you go. What's up? Good. This is quite literally the like I keep saying, guys, this is the next natural progression thing that we talk about in here. And we will probably do this for a good day and a half just to make sure we got this down, because then the next step is to find everything. And it really, once you get going into this, it's only one more step, really. Okay. Yes, sir. Absolutely, man. Absolutely. Let's try another one. Oops, wrong one. Okay. Take a minute or two. Try those two. Label. Write out the trig. Show me what you're going to press in the calculator. Okay? You all right, man? I'm sorry. You get the funk. Yeah, the software that I use to make this up puts a question mark there. Sometimes it might be X, sometimes it could just say angle.
But it's always saying.
Yeah, it'll say find that angle. You know, find the indicated angle measure. And then it'll be round to the nearest 100.
Okay.
That's usually the instructions that you will see for something like this. Okay? All right, so here's my theta. 37 is its opposite. 40 is its, what trig function is that? Sine. Sine of theta, 37/40, which means I have to inverse sine. What'd you get?
67 or 67?
Anybody agree, disagree? Is it the end of the world if you forget to put a degree symbol there? No. Not at all. Oh, look at this. We have another sign. Hey, don't think that every function is always going to be signed. Sometimes it doesn't randomize it as nicely as we hope. Okay? So again, you have a sine value. Sine of theta, 15 over 28. People have asked before, sometimes these fractions can be simplified. Do you need to do that? Why? Just put it in the calculator. Doesn't matter. Not at all. Will it matter next year? Yeah, it'll be very helpful next year to simplify some of these fractions because as you get into Algebra 2, you don't deal so much as far as degree measures. You start looking at radian value. And you'll have to know from what specific values and what quadrant you're looking for. You're looking for a positive or a negative angle depending upon where sines and cosines and tangents are positive or negative. Yes, you could have a negative angle, which is not yet. Next year. What's that? You probably have a year after that too.
Is there any way to like do average
Yes.
from like shipping sign?
No. There is a way to do this without a calculator if you knew how to find the decimal equivalent of 15 over 28. So if you took, this is Thrower and I did this back in our day. $28 goes into 150. Well, 25 would go into 156 times. Which means 28 is bigger, so it probably goes in only 5 times.
Do they teach students how to like estimate?
No.
No.
That'll be a 3. What's 484? So that would be another 5. Mrs. Thrower, do you have your trig table on you by chance?
I don't
Oh.
because I brought it home. I just thought no one minds.
All right, well, I can Google it real quick. So 200, this will be a 6. What's 8, 4, 12, 1, whatever, we'll do that. So,
I'd rather.
is there a trig table? I think there's one in the back of the book.
I can Google one. It's I don't like it.
So, what we would do back in the day, if not, I'll just pull one up online real quick.
Meaning when he was like, I don't know,